Okay, let's start with our preparation for test 4. So far we have done, if we take a look on the table of content, then we have done 6.2, 6.3, 6.4. 6.2 is on trig equation. And 6.3 is addition, subtraction. That's the group 1, formula group 1. 6.4, formula group 2, and group 3. We still have actually quite some material to go over. Like 6.5, I think that's group 4 and 5. 6.6, that's inverse trig, which we will go over tomorrow on Tuesday, Thursday class. And then 7.1, 7.2, that's law of sines and cosines. And 9.2 to 9.5, as I remember. Okay, so far we only cover not a lot. We have not covered a lot. But you will see that given that we have covered this 6.2, 6.3, 6.4 only, we can do actually around 7, 8 problems from fall 20 and 5 problems from spring 20. And 1/3 of the test, actually, 1/3 of the test can be done already. Okay, and I can say that the one from 7.1, 7.2, those are actually just applying formulas. And 9.2, 9.3, 9.4, 9.5 are actually learning patterns. Okay, so those are the easy part. If anything difficult, actually later on has something to do with 6.6. Okay, so we are only 1/3 so far. We only finished 1/3 of test 4 material so far. But by the end of this week, we should have finished up to chapter 7, and therefore we finish like around 80% of test 4. Okay, so this Thursday, I think this Thursday we'll be working on these 2 cases here. Yeah, which is not a lot, actually, not a lot of material. Okay, let's start. In fact, what we will do today is actually quite crucial, important. This type of question I always ask. Now let's see. Question number 1. I will start from spring 20. There are 5 problems to work on here. And question number 1 is a very long one. Okay, let's start. Tangent A is it's -3/4. Angle A is in quadrant 4. So tangent A hat, the reference angle is 3/4. Right now, I hope you realize why I do this, because I want to catch the right triangle. Okay, in my opinion, this is actually the best way to attack this type of question. Attack that from the reference angle. Okay, a tangent is 3/4, so hypotenuse is 5. Okay, so later on, when we work on sine A hat, sine A hat is 3/5. Now then sine A, it's in quadrant 4, sine is negative. Okay, cosine A hat is 4/5. In quadrant 4, cosine is still positive. So cosine A is positive 4/5. Okay, now cosecant B is 13/5. B is in quadrant 2. So I make it reference angle, okay, but still positive. Now my B hat, the reference angle is in quadrant 1, right? Now then do the triangle. Sign change numbers as hat change. Basically, when we do a hat, it means we are talking about the reference angle. Reference angle. Reference angle of A. Now, reference angle must be in quadrant 1, therefore we can put that in a right triangle. Does it make sense? Okay, cosecant B hat is 13 over 5. Cosecant is reciprocal of sine, so this is 13, this is 5, this must be 12. Okay, then their hypotenuse is still 5. That's right, yeah, their hypotenuse is still 5. That's right. The other alternative, let's go back to that tangent A equals to negative 3/4, A is in quadrant 4. The other alternative is actually you draw the angle A in quadrant 4. Okay, tangent negative 3/4 means the y is negative 3. The x is positive 4. The hypotenuse is still 5. Like that. So this is 4 comma negative 3. Like that. Now, if you see there, then the sign will be negative 3. Oh, I think I make mistake here. Now I see. So this should be 5. That's a typo. Should be 5 here. Now I see that. Okay. Is it okay now? Yeah, so yeah, that's 3/5. Okay. The sine is y over r, cosine is x over r. Right. So that's the alternative if you want to deal with the quadrant 4 right away. Now I have a tendency to deal with that from reference angle point of view. So sine B, well, sine B is 5/13. That's just the reciprocal of cosecant B. Now cosine B hat is 12/13. Now B is in quadrant 2, so cosine is negative. Tangent B hat is 5/12. Now in quadrant 2, tangent is negative. Like that. Okay, so you see that I actually spend more time on the setup. Then we go on. Question A, what is cosine A plus cosine B? Write down the formula first. Cosine A cosine B minus sine A sine B. Cosine A is 4/5. Cosine B is negative 12/13 minus sine A is negative 3/5. Cosine B is, I'm sorry, sine B is 5/13. So this will be negative 48/65 plus 15/65. That will be negative 33/65. I hope I don't make miscomputation. Cosine A is positive, cosine B is negative, sine A is negative, sine B is positive. Yeah, okay, that's good. Okay, now that's for cosine of sum. Now how about tangent of sum? Tangent of sum is sum of tangents. Write down the formula first. Over 1 minus product of tangents. Okay, and then plug in numbers. Tangent A is negative 3/4. That's actually in the question. Plus tangent B is negative 5/12. 1 minus negative 3/4 times negative 5/12. Okay, let me simplify a little bit. This is negative 3/4 minus 5/12 big over 1 minus 15 over 48. Multiply the top and the bottom by 48, the LCD. Give me, on the top left, that will be negative 36. On the top right, that's negative 20. 48 minus 15, that's negative 56 over 33. Okay. Now then, because cosine and tangent are negative, then these two angles must be in quadrant what? Cosine of A plus B is negative. Tangent of A plus B also negative. Now that implies A plus B must be in quadrant 2. Okay. By the way, I would like you to actually take a look on some side note. This is not important, but call that a side note. Notice that we actually obtain Pythagorean triplets. If you take a look on this A plus B hat, the reference, I use reference angle. Okay. Okay. So now cosine A plus B hat is 33 over 65. Now the tangent is 56 over 33. Now, do you notice that we actually obtain a Pythagorean triplet here? Pythagorean triplets is Pythagorean triple is a number, is a set of three numbers, three integers that satisfy Pythagorean theorem. Okay, so we actually get that. Therefore, you will see that we have infinitely many Pythagorean triples actually. Okay, that's just a side note. Okay, let's go on with part D. What is cosine 2b? Cosine 2b is, there are three formulas. Which formula do I want to use? Cosine 2b, let me use the sine version. Yeah, let me use the sine version because sine b is 5 over 13. Is it right? Let me confirm again. Yeah, sine b is 5 over 13. So let me use the sine formula. You can use any one of those three variations though. Okay, but I will use 1 minus 2 sine squared b. That's 1 minus 2 times 5 over 13 squared. That's 1 minus 2 times 25 over 169. This is 169 over 169 minus 50 over 169. That's 119 over 169. Now tangent 2b will be 2 tangent b over 1 minus tangent squared b. What is tangent b? Let's see above. Tangent b is negative 5 over 12. That's negative 10 over 12 over 1 minus 25 over 144. Now multiply by the LCD, 144 over 144. I get negative 120 over 144 minus 25. That's negative 120 over 119. Okay, now let's see, part F. Which quadrant is angle 2B located? Well, cosine 2B is positive, yet tangent 2B is negative. So from here we see that angle 2B must be in quadrant 4. Okay, that's for part F. Let's go on. So the reasoning is actually quite short, right? I say provide the reasoning, and your reasoning is this. That's it. Okay. Let's go on. Which quadrant is angle A over 2 located? Now, we don't have the sine, we don't have the cosine, we don't have the tangent, but we know A is in quadrant 4, right? That's what they tell us, which means this angle A must be between 270 degrees to 360 degrees. Now, when we divide by 2, this becomes 135 degrees to 180 degrees. Okay, which means this angle A over 2 must be in quadrant 2. Okay, now then we use that to help us using finding this cosine A over 2 is, well, A over 2 is in quadrant 2, so it must be, cosine must be negative square root of 1 plus cosine A over 2. Okay, now what is cosine A again? Let me take a look. Cosine A is 4/5. Cosine A is 4/5. So this is negative square root of 1 plus 4/5 over 2. Let me multiply the top and the bottom by 2 inside the square root. So I get negative square root of 2 plus, I'm sorry, not by 2, by 5, I meant. Why 2? By 5, the top and the bottom by 5. That way, then the first term on the top becomes 5, the second term becomes 4 over 10. That is negative square root of 9 over 10. Now multiply the top and the bottom by 10. I will get 3 square root of 10 over 10. Well, this is negative 3 over square root of 10, right? And then rationalize the denominator. Now, I skipped question number 2 because it requires us some knowledge in inverse trig function. Okay, so tomorrow we will learn inverse trig function, and then on Wednesday we will work on this. If we have enough time today, then I may just go ahead working on this problem. Okay, but I'm actually not rushing though. No, I prefer just to hold this until Wednesday. Okay. let's see, number 3. Oh, solving equations. This is 6.2 part. What we just did is 6.3 and 6.4. Now, number 3 is actually 6.2, but with some knowledge from 6.4. Okay, a solution. Sine t equals to cosine 2t. We have double angle, cosine. There are 3 variations, but the other side we have sine t. Now, because we have 3 variations for cosine 2t, we will use the variations that only have sine. That is 1 minus 2 sine squared t. Okay, then when you can factor, you factor. So sine t equals to 1/2, sine t equals to -1. When sine t equals to 1/2, then that will be, oh, in radians, so that will be 30 degrees, pi over 6 plus 2 pi k. And in quadrant 2, that's 5 pi over 6 plus 2 pi k. -1 means t equals to 3 pi over 2 plus 2 pi k. Okay, so those are the solutions. Now, remember, once you have this kind of factoring equals to 0, then the next line, you break it into 2 branches. Okay, break it into 2 branches. You must have enough space. Don't worry. You must have enough space. Do not do it this way. Do not do it this way. I have seen this before. I honestly don't like it. Like, so we have 2 sine t minus 1 sine t plus 1 equals to 0. And then they work on the sine t equals to 1/2 first. And t equals to what? And then later on they write sine t equals to -1. And then they solve it. No, this is actually not a correct way to write. Okay, if you really want to write it this way, then you put, okay, this is the first branch, this is the second branch. Okay, now here's the thing though, because of the way you write, this is just the way you write though. But the thing is, like, of let's say of 10 people writing it this way, at the end only 1 or 2 of them end up passing. So it has something to do with the way you write, and this is just a reflection of the way you think. The way you write is basically just a reflection of the way you think, right? Now, if you do it this way, it means I know that you are actually working on this first, and then after that you work on that. But these guys supposed to be simultaneous. Okay, they are at the same level. So that's how you're supposed to write it. Okay, so as if the way you think is like, okay, then if I have this a times b equals to 0, either a equals to 0 or b equals to 0, and from there, so we have 2 branches, and then from there we solve it one for each. Okay. The way you're supposed to write, I tell you, okay, do it this way or do it that way. I know sometimes other teachers just say, oh, Thomas, it's just a way of writing. Why do you want to penalize students? But the way I see is this. I also observe those students who are doing well and students who are not doing well. Compare how they write and see which one is more successful. Okay, is that a correlation? We don't know. Like, I mean, correlation in the sense, is it possible that because the way they write result in better grade? That one, I'm sure that's true. But is it possible simply because of different way of writing, Thomas, they end up being successful or not? That's what I was trying to find out. And there are some cases where I can tell you more. like in this one here. Okay, every time you have solving equation by factoring, you have two branches or more, always write them next to each other. Okay, and then you kind of like break it up into that branches. Okay, this branch, this is the solution. This branch, this is the solution. This branch, this is the solution. Like that. Okay, now if you want to pile them up on the top of each other, then you use the bullet, the one I showed you earlier. Okay, now this is for all solutions in radian, for all t in radian. That's why I need to put plus 2 pi k. Okay, that's for number 3. Number 4. For all these angles here in degrees from 0 to 360, solve for this tangent squared blah equals to 3. So tangent blah, I apply the square root property. Tangent blah equals to plus minus square root of 3. Okay, now then because we have two branches, then I will break it up. Tangent blah minus 50 degrees equals to square root of 3. That's the first branch. The second branch, tangent of blah equals to negative square root of 3. It's actually just that simple. Strangely, plenty of students actually didn't know how to do this problem. More than half, while it's supposed to be on the easy side. Don't worry about the angle. We worry about that later on. Okay, because when you apply the square root, hey, that's the value of a special trig functions for tangent, right? Okay, now then from there we see, oh, if that's the case, then 2 theta minus 50 degrees must be 60 degrees or 180 degrees K. Right? And then for the second branch, let me move this a little bit to the left. The second branch, we have 2 theta minus 50 degrees equals to 120 degrees plus 180 degrees K. Right? Now then from there we solve. So 2 theta equals to 110 plus 180 degrees K. Theta equals to 55 degrees plus 90 degrees K. 2 theta equals to 170 degrees plus 180 degrees K. So theta equals to 85 degrees plus 90 degrees K. Now then the solutions, when K equals to 0, theta equals to 55 degrees, theta equals to 85 degrees. When K equals to 1, theta equals to 145 degrees, theta equals to 175 degrees. How far do we need to go, Thomas? Until you go beyond 360 degrees, then you stop. Okay, so these are the solutions in the first interval from 0 to 360 degrees. That's number 4. Number 5. For angle in the first interval from 0 to 2 pi, it means the t is in radian. Secant t over 3 is negative 2. So solution, cosine t over 3, therefore, is the reciprocal, right? Now, then t over 3 must be what? in quadrant 2 and quadrant 3. In quadrant 2, that is equivalent to 60 degrees. That's 2 pi over 3 plus 2 pi k. Okay, in quadrant 3, that is 4 pi over 3 plus 2 pi k. Right, in quadrant 2 and quadrant 3. Now multiply by 3, you get 2 pi plus 6 pi k. T equals to 4 pi plus 6 pi k. So the question is actually not too hard, right? Okay. Yeah, but you see when k equals to 0, it's already outside. Right? Okay. So no solution in the interval from 0 to 2 pi. Okay, let me mark it Y. So that's the reason we say no solution. It's not that it doesn't have any solution. No, it does have some solution, but it happens there's no solution in that first interval. Okay, that's for number 5. Let's go on with the last question from this problem set that we can do, number 6. We can do this number 6 on Wednesday because this is actually from section 6.5, which we will do tomorrow in Tuesday, Thursday class. So on Wednesday, we will be able to do this. Okay, maybe I mark question number 2. This is from section 6.5. Okay, inverse trig functions. Number 7. Oh, this one. Oh, the one that I show you 2 different ways to do that. Okay, yeah. Let me show you. Let me do it with the unit circle approach. Okay, I will use unit circle approach, and then later on, for conventional way, see last page. Okay, but I will do using unit circle approach. Let A comma B equals to cosine x sine x, that be on the unit circle. So the equation, the system of equation I need to solve now is b minus square root of 3a equals to -1, and a squared plus b squared equals to 1. In the past, I used x and y for the coordinates, right? But the x already being used here. I cannot use x anymore. I cannot say x comma y equals to cosine x sine x. No, you have 2 different definition of x if you do so, right? Now to make it consistent, then I use a comma b as my dummy for xy. Okay, for the coordinates. So my coordinate system right now, instead of x and y axis, I use a and b axis. What do you mean? What do you think? Is it okay? Instead of using x and y, which confused with that x in the equation, I use a comma b. Okay, now then from equation 1, we see that b equals to -1 plus radical 3a. So when I square it, I get -1 plus radical 3a being squared, which is 1 minus 6, I'm sorry, minus 2 radical 3a plus a squared. Now, pushing that into equation 2, so a squared plus b squared equals to 1. Okay, so we have 2a squared minus 2 radical 3a equals to 0. I can divide by 2, but let me factor 2a out, so I get a minus radical 3 equals to 0. Okay, so either a equals to 0 or a equals to radical 3. Okay, but the thing is like a equals to radical 3, this is greater than 1, right? Okay, so in other words, under no situation a squared plus b squared will be equals to 1, right? Because the distance from origin is already more than 1. Okay, so only a equals to 0 left. Now, if a equals to 0, what is b? It's negative 1 plus radical 3 times 0. B is negative 1. So the coordinate now, 0, comma, negative 1, right? That's the coordinate. But 0, comma, negative 1 implies the x is 3 pi over 2. Okay, is it in? Yeah, it's in radian. That's the answer. Okay, that's for this question. Now, let's try to do this using a longer method. I want to copy that, but how? Okay, let me do it this way. Give me a second. Okay, so I will put it at the very last part. Let me do it here. Okay, let's do it the regular way. The regular way is we isolate one of the trig functions, right? So let's say, let me isolate the cosine part. So sine x plus 1 equals to radical 3 cosine x, and then I square both sides. Now the weakness of this method is because we square both sides, then the final answer, each final answer we have should be checked against the original equation. Okay, so this is sine squared x plus 2 sine x plus 1 equals to 3 times 1 minus sine squared x. So we get 4 sine squared x plus 2 sine x minus 2 equals to 0. Reduced by 2. Oh, it is factorable. Okay, so it will be 2 sine x minus 1 sine x plus 1. Okay, now then sine x equals to 1/2 or sine x equals to negative 1. This will be 3 pi over 2 in the first period. We just need the first period. Okay, now x equals to pi over 6 or 5 pi over 6. But we need to check, right? Remember? Okay, so I need to check. So check. Checking x equals to pi over 6. Is sine pi over 6 minus radical 3 cosine pi over 6? equals to -1. This is 1/2 minus radical 3 times radical 3 over 2. Is it equals to -1? Huh? That's true though. Hold on. Am I missing something up there? Give me a second. Hey, I must have done some miscomputation somewhere here. Ah, good thing I checked that. So I'm missing a 3 here. You see that? I'm missing a 3 here. So it should be 4. I need to correct this though. So this is now 4. And this is 2 here. So I need to correct this part here. I'm sorry. Yeah, I'm missing a 2 there. I'm missing a 3 there. So this is radical 3 over 2, and therefore B is -1 plus radical 3 times radical 3 over 2. That is -1 plus 3/2. That's 1/2. The coordinate radical 3 over 2 comma 1/2 give us angle is pi over 6. 30 degrees, right? 30 degrees give us this angle, this coordinate on the unit circle. Now let me go back there. Yeah, good thing I did it with the second way. But that's a silly mistake. I missed that. So this is 1/2 minus 3/2. Is it equals to -1? That's true. That's a check. X equals to 5 pi over 6 sine 5 pi over 6 minus radical 3 times sine times cosine 5 pi over 6. Is it equals to -1? This is 1/2 minus radical 3 times negative radical 3 over 2. This is 1/2 plus 3/2. That's 2 not equals to -1. So 5 pi over 6 does not check. How about 3 pi over 2? Sine 3 pi over 2 minus radical 3. Let me move it down. Times cosine 3 pi over 2. Is it equals to -1? So this is -1 minus square root of 3 cosine 270 degrees is 0. Okay, so -1 equals to -1. That's a check. Now then you need to summarize. So x equals to pi over 6. X equals to 3 pi over 2. Okay, that's for this section. And I show you 2 different ways to do that, number 7, right? Okay, if you ask me to do it myself, like I don't need to show my work to other people, I will use unit circle approach. Okay, I will use unit circle approach. Now, but most of the time, instructors and textbooks use this last method here. Okay, now let's go on to fall 20. Let's go on to fall 20. I would like you to set this up. In fact, let me ask you to do number of 1, A, B, C. So question C is, part C is A minus B is in which quadrant? Okay, so I would like you to set it up. Okay, and then do A, B, and C. That should take you approximately 10 minutes. Let's say I give you 15 minutes, 14 minutes from now to do this problem. Okay, so I will come back at 10:30. Okay, you try to do that first. Okay, let me start. So I go ahead with sine A. Okay, sine A will be positive because it's in quadrant 2. That's 1 over radical 5. Cosine A, that's negative because again A is in quadrant 2, 2 over radical 5. And tangent A, that's just the reciprocal of cotangent. Okay, and then for secant B equals to, secant B hat equals to 3. That's 3 over 1. So this is square root of 8, which is 2 radical 2. Now then, you know what? Let me do it this way instead. Now then, from there, sine B, B is in quadrant 4, so sine is negative. That's 2 radical 2 over 3. Cosine B, that's just a reciprocal of secant B, that's 1/3. Tangent B will be negative 2 radical 2 over 1. So then sine A minus B is sine A cosine B minus cosine A sine B. That's 1 over radical 5. Cosine B is 1/3 minus cosine A is negative 2 over radical 5. Sine B is negative 2 radical 2 over 3. That's 1 minus 4 radical 2 over 3 radical 5. Now we need to rationalize, right? Okay. Multiply by radical 5 over radical 5. We get radical 5 minus 4 radical 10 over 15. And of course, you can tell right away that this is negative, right? Yeah, because on the numerator, radical 5 is less than 4 radical 10. Now, how about the cosine? Cosine A minus B is cosine A cosine B plus sine A sine B. Cosine A is negative 2 over radical 5. Cosine B is 1/3, as I remember. Plus sine A is 1 over radical 5. Sine B is negative 2 radical 2 over 3. So this will be negative 2 minus 2 radical 2 over 3 radical 5. Rationalize the denominator. We get negative 2 radical 5 minus 2 radical 10 over 15, which is also negative. Okay, now that tells us that which quadrant are this angle A minus B located. Sine A minus B is negative. Cosine A minus B also negative. Then from there we see A minus B must be in quadrant 3. Okay, now let's go on. How about tangent 2A? Tangent 2A is 2 times tangent A over 1 minus tangent squared A. What is tangent A, by the way? Negative 1/2. So this is 2 times negative 1/2 over 1 minus negative 1/2 squared. That's negative 1 over 1 minus 1/4. Multiply the top and the bottom by 4. I hope that solved our problem right away. That will be negative 4 over 4 minus 1. That's negative 4/3. How about sine 2A? That's 2 times sine A cosine A. Sine A is negative 1 over radical 5. I'm sorry, positive 1 over radical 5. The cosine is negative 2 over radical 5. So this is times 1 over radical 5. Negative 2 over radical 5. That's why I didn't rationalize the denominator for sine A cosine A, because I will use those numbers later on anyway. This will be negative 4 over 5. Now, tangent is negative, sine is negative. So, tangent 2A is negative. Sine 2A is also negative. So, 2A must be in quadrant 4. Okay, now which quadrant is angle B over 2 located? Now, angle B is in quadrant 4, right? Which means B is between 270 degrees to 360 degrees. Now, when we divide B by 2, that interval should be divided by 2 also, which implies B over 2 is in quadrant 2. Okay, because it's between 90 to 180 degrees. So what is cosine of B over 2? Cosine of B over 2 in quadrant 2 is negative square root of 1 plus cosine B over 2. What is cosine B? 1/3. Let's multiply the top and the bottom by 3 first. So I get 3 plus 1 over 6. That's actually for 6 or 2/3. square root of 2/3. Now then I multiply by radical 3 on the top, and the bottom I have negative radical 6 over 3. That's for number 1. Number 2, just like before, I skipped that for now. Let's go on to number 3. Solve for all radian cosine 2x, not 2 cosine x, not cosine square x, no, cosine 2x minus cosine x minus 2. There are 3 variations. I believe we will use the first variation, the second variation, 2 cosine squared x minus 1 minus cosine x minus 2 equals to 0. Okay, so 2 cosine squared x minus cosine x minus 3 equals to 0. 2 cosine x, cosine x, I need minus 3. So minus 3 here, plus 1 here. Will that do? Okay, so cosine x is 3/2, which not apply. No such x, to be more precise. Or cosine x equals to -1. So x is all t in radian, so it should be all x in radian. That's negative pi, huh? Negative pi plus 2 pi k. Okay, that's for number 3. Now, how about number 4? Sine theta over 2 minus sine theta equals to 1. When you deal with half angle equation, there are actually 2 ways to do this. Okay, but let me show you my favorite work first. Okay, let me show you my favorite works first. Instead of attacking that from half angle, I will do substitution, and we deal with double angle instead. So let t or x equals to theta over 2. Now, of course, then theta equals to 2t, right? Now, then I have sine t minus sine 2t equals to 1. Now, you solve for t, okay, and theta will be twice of that. Okay. I don't remember how to solve this problem though. I don't remember how to solve this problem. I know pi 180 degrees is one of the solution. Yeah, 180 degrees is one of the solution, but let's see. Okay, so sine t minus 2 sine t cosine. Oh yeah, that's right. The problem is this. See, I want to factor this, but the problem is on the other side, it's 1, it's not 0. Do you see that? Okay. Now, I will show you later on how to go on from there. But we know that theta equals to pi 180 degrees is one of the solution. Okay, do we have other solutions? I don't know. But I will go on from there later on. Now, let me show you first how other people, you know what? Let me do it this way. So I kind of suspect I may have some issue later on here. Theta over 2 equals to 1 plus sine t, sine theta. Okay, I will square both sides. What is the reason, Thomas, you square both sides? Because we have formula for sine squared blah. That is 1 minus cosine theta over 2. equals to 1 plus 2 sine theta plus sine squared theta. Okay, so this is 1 minus cosine theta equals to 1 plus 2, I'm sorry, 2 plus 4 sine theta plus 2 sine squared theta. I really don't like this. Even this way is not something I can do easily. Do you know why? Because I can change this to sine or cosine, but I cannot really play around with this. Okay, I still have cosine and I still have sine. You see that? Okay, so it seems like I have no other way but do some, you want to call that magic. Okay, it's not something you have not seen though. I mean, at least, you know what? I'm sorry. I can cancel the 1, right? So this is negative cosine theta. I can cancel the 1. And plus 2 times 1 minus cosine squared theta. But there's no need. There's no need. Just leave it as sine then. Hey, I have this equation. How do we solve this? Use unit circle. Let xy equals to cosine theta sine theta. Okay, so negative x equals to 1 plus 4 y plus 2y squared. Okay, at the same time, we also know that x squared plus y squared equals to 1. Now, how do we solve that? Now, that's where the painful part starts. Honestly, I don't know how to solve this. I try using, earlier I used double angle, and once I saw that, oh, it's difficult. So either way it will be difficult. So let's do the traditional way first. This is the traditional way, but I cannot avoid using unit circle. Oh, how do I solve this? So maybe negative x equals to 1 plus 4y plus 2 times 1 minus x squared. So negative x equals to 1 plus 4y plus 2 minus 2x squared. Still no. So 2x squared minus x minus 1, actually minus 3 equals to 4y. I'm not going anywhere. Okay, seems like that's the only way. So equals to 4y. So I make it like this. 4 square root of 1 minus x squared, like that. And then I square both sides again. Dang, that's painful. You know what? Let me skip this question first. Let me skip this question first. I don't want to waste too much time here. I do it later. Okay, number 5. Number 5. Solution. The way I did this problem earlier, let me tell you how I get this first. In the past, I actually have this question originally, cosine theta over 2 minus cosine theta equals to 1. No, that's what that's what the original question is. And then the way I thought was like, oh, you know what, if I change it to sine, it should work. And when I look at this, I know pi, or 180 degrees, is one of the solution. So it must have a nice solution. I just didn't realize that it will take so much to actually to get the work. Okay, to get the work. It is also the reason, one of other reason I gave this question was to detect who among the students still use photomath, and apparently photomath will give you, or any software, if you try to solve that using software, any software will give you a very strange method, Okay, now going back to number 5, we have 2 cosine x plus sine x over cosine x equals to 1 over cosine x. So I will multiply by cosine x with the notion that it cannot be 0, right? Cosine x cannot be 0. So I will get 2 cosine squared x plus sine x equals to 1. So this is 2 times 1 minus sine squared x plus sine x equals to 1. Negative 2 sine squared x plus sine x plus 1 equals to 0. Get rid of the negative. I believe I can factor it after this. Yeah, I multiply by negative 1. Right, so I get 2 sine x plus 1 sine x minus 1 equals 0. So sine x equals to 1. X is pi over 2, right? But cosine pi over 2 is 0. So I have to reject this. Because cosine pi over 2 equals to 0. Okay, now we are left with sine x equals to negative 1/2. So x will be, is it in radian or in degrees? In radian, okay. So sine negative 1/2, the angle must be in quadrant 3, which is 7 pi over 6, and quadrant 4, 11 pi over 6. Okay, that's for number 5. Oh, number 6, that's something we did earlier, right? There are 2 methods. Okay, you know what? Let me ask you to do this number 6. I always have this question, right? Let me ask you to do this number 6. Use, if possible, use the unit circle approach. So let me give you some idea. So let xy equals to cosine theta sine theta, and then solve it from there. Okay, so we get radical 3y minus x equals to radical 3, and then x squared plus y squared equals to 1. Now try using that method first. Okay, while I will start thinking about this question here. I wonder how I did that. at that time. Let me write it down first. Give me a second. Okay, let me ask you to do this problem together with your break. Yeah, together, number 6. Let's say you do that in around 7 minutes, and then 10 minutes break. We come back at 11:10. Okay, I look at my solution from last semester for that question, and yes, this was a typo question. This was a typo. The original question, the question supposed to be cosine here. Yeah, supposed to be a cosine there. Okay, so that was a typo from last semester. So let me do number 6 first, and then I go back to this number 4. Okay. So number 6, this will be square root of 3y from equation 1 equals to radical 3 plus x. Oh, you know what? I will isolate the x instead. So negative x equals to radical 3 minus radical 3y. So x equals to radical 3y minus 1. When I square, I get 3 times y minus 1 squared. Plug that into the equation 2. I get 3 times y minus 1 squared plus y squared equals to 1. So 3 times y squared minus 2y plus 1 plus y squared equals to 1. 4y squared minus 6y plus 3 plus 2 equals to 0. Reduced by 2. So we get 2y minus 1, y minus 1 equals to 0. Y equals to 1/2, y equals to 1. So x equals to radical 3 times 1/2 minus 1. X is negative radical 3 over 2. So the coordinate negative 3, radical 3 over 2, 1/2. That is for theta equals to 5 pi over 6. Is it in degree or radian? Okay, radian. For y equals to 1, so x will be radical 3 times 1 minus 1, that's 0. So the coordinate 0, 1 will be corresponding to theta equals to pi over 2. Okay. Now that's the standard way. This is the unit circle approach. Suppose I do the standard method. Radical 3 sine theta minus cosine theta equals to radical 3. Let me do it here. Radical 3 sine theta minus cosine theta equals to radical 3. Isolate the radical 3 sine theta. Okay, so this is number 6, alternate way, the long way. Then I square both sides. 3 sine squared theta equals to 3 plus 2 radical 3 cosine theta plus cosine squared theta. Oh, you know what? Let me change the sign instead. Yeah, because I have cosine theta here. So this is 3 times 1 minus cosine squared theta. So that's becomes 0 equals to 4 cosine squared theta plus 2 square root of 3 cosine theta. And the 3 cancels. So I can factor 2 cosine theta here. Okay, so we get cosine theta equals to 0 or cosine theta equals to negative radical 3 over 2. Cosine theta is 0 when theta equals to pi over 2 or 3 pi over 2, right? While cosine theta is negative radical 3 over 2 means theta is in quadrant 2 or quadrant 3. So 5 pi over 6, 7 pi over 6. Now the thing is we need to check which takes longer time. Okay, you need to show the check though. Now from above we already see that pi over 2 will work. Right? Pi over 2 radical 3 cos sine pi over 2 minus cosine pi over 2, that is radical 3. That's radical 3 times 1 minus 0. Is it equals to radical 3? Radical 3 equals to radical 3. That's check. That's for theta equals to pi over 2. Now, I don't think you can try it yourself, go on yourself, 3 pi over 2, it will not work. Okay, it will not work. It will give us negative radical 3, which is not equal to radical 3 instead. Okay, for 5 pi over 6, it will work. But 7 pi over 6 will not work. Okay, but you need to show the check. That's why I don't like this method. I don't like this method. I try to avoid squaring both sides of cosines because I have multiple solutions, and those multiple solutions I need to check one by one. Now, let's come back to this number 4 for the questions that I modified already. Okay, I modified this already. So let me say that that's a typo here. It's supposed to be cosine. Okay, that's supposed to be cosine. So if I move it to the other side, that will be cosine here. And then this will be cosine, this will be cosine, this will be cosine. Multiplied by 2, this will be cosine, this will be cosine. Okay, at least that's how far we go. That unit circle approach will be useful to work on problems in trigonometric equation in which you need to square both sides. That's actually a good substitute. Okay, that's a good substitute. I got the answer for the earlier question though, but it's just beyond your level. It's just beyond your level. So I can't really work it out. Okay, so I set one side equals to 0. I get 2 cosine squared theta plus 5 cosine theta plus 1. I don't think this is factorable, is it? Yeah, I don't think this is factorable. So theta equals to, cosine theta equals to negative b plus minus square root of b squared minus 4ac over 2a. Negative 5 plus minus square root of 17 over 4. Okay, so we have cosine theta equals to the positive branch. No, this is still negative branch. I'm sorry. This is the negative branch. But this is even more negative branch. But I want you to realize that the second branch here is even less than negative 1. So no solution from this branch. Okay. Now then, theta will be, this is in quadrant 2, right? Okay, so let's use the reference angle. Theta hat equals to 5 minus square root of 17 over 4. The opposite of what we have here. The opposite of what we have here. That give us theta hat equals to cosine inverse of 5 minus radical 17 over 4. Basically, that gives us angle in quadrant 1, but cosine is negative in quadrant 2 and quadrant 3. So to make it in quadrant 2, that will be pi minus this result here. And the angle in quadrant 3 will be pi plus that reference angle. Now, this is a good exercise for the situation when you cannot actually factor it. If we cannot factor it, then you use quadratic formula, but then the angle, very likely not a nice one, right? And can you overcome that? Okay. Now, the thing is, because we square both sides, we still need to find, I'm sorry, we are not done yet. I forgot. I need to check this. I need to check this. Okay, but just check using your calculator. Okay, just check using your calculator. Yeah, the answer in quadrant 3. Oh no, I don't know. I don't know. You need to check. Yeah, you need to check it in full. Okay, just use calculator to check. Well, because of the time I have, I don't think I want to spend more time here. I will do number 12, 13, 14. Okay. Hopefully we have time to finish it. But what I want to say is, like, is it possible for us to do this without calculator, to check this without calculator? It's actually very possible, but you need to learn the inverse trick first. Okay, so far we can only use inverse trick once we have unit circle. I'm sorry, once you have angle in quadrant 1, then we can use inverse trick. Right, but no, it's not doable yet at this time until we learn section 6.6. Okay, now this test already have section 6.6. So when they took this test, they already learned section 6.6. You are not yet. Okay, so it's not that I cannot go over. It's just like what you know. I have to assume you have not learned inverse trick in other quadrant. Okay, now let me go on to number 12. Number 7, for example, that's something we learn in 6.5. Okay, now number 9 here, this is 7.1, 7.2. This is 7.1, 7.2. Okay, that's 7.1. Number 12, proofing, which we actually have done. This is 6.1 actually. Okay, but let's do it again. Let me prove from left to right. I will multiply the top and the bottom by the conjugate of the denominator. The purpose is such that on the denominator, I will get 1 minus cosine squared t, the difference of squares. And this is equal to sine t 1 plus cosine t over sine squared t. And then we cancel one of the sine t. That's what we have on the right hand side. That's the end of the proof. That's for number 12. Where's my number 13? Oh, number 13 here. Expand sine 3 theta to in terms of sine theta or the power of sine. Basically, we do not want double angle. We don't want multiple angle, but we are okay with power of sine. Okay, so sine 3 theta equals to sine 2 theta plus theta. That's sine 2 theta times cosine theta plus cosine 2 theta times sine theta. Now we want them in sine, right? We want them in sine. So if as much as possible, we change it into sine. So this is 2 sine theta cosine theta times another cosine theta plus this is 1 minus 2 sine squared theta cosine theta. This is 2 sine theta cosine squared theta plus sine theta minus 2 sine cubed theta. I changed the cosine squared theta into 1 minus sine squared. So I get 3 sine theta minus 4 sine cubed theta. Okay, that's for number 13. Last one, number 14. Proof. Hold on. This actually requires 6.5 though. This is requires section 6.5. But I wonder if we can do it without section 6.5. Is it possible? No, it's impossible. No, so I cannot do number 14. I cannot do number 14. At least not yet. Okay, is there other question after this? No, this one is not doable. This is actually 7.1, 7.2. Yeah, in your test later on, I will give you the formula for sum of product, as product to sum formula, sum to product formula. Okay, so question number 14. Where is that number 14 earlier? This one here, you can use that formula if you want. Okay, we can use that formula. Let me just do it while at the same time killing time, right? The proof. I will start from left-hand side. I mean, right-hand side to left-hand side. I have sine 3x minus sine x over cosine x minus cosine 3x. We will learn this tomorrow in Tuesday, Thursday class, on Tuesday, tomorrow. But we have the formula. So let's just use the formula. Okay. Okay. Sine minus sine, sine minus sine, this is the formula. Okay. And then the top one is what? The top one sine minus sine, the bottom one cosine minus cosine. Cosine minus cosine, this is the formula. Okay, so I will just apply this right now. Okay, sine minus sine is 2 cosine this, sine this. Okay, let me write it down up there. You write it down up here, which formula we use. So sine x minus sine y is equal to 2 cosine the sum of those two angles over 2 sine of the difference of those two angles over 2. While for cosine x minus cosine y, that will be negative 2 cosine, I'm sorry, cosine minus cosine, actually sine sine. So negative 2 sine sum over 2 sine difference over 2. Those are the formulas. So using those formulas on the top, you see on the numerator, sine 3x minus sine x. Sine minus sine is 2 cosine the sum over 2 sine difference over 2. On the denominator, we have cosine minus cosine, that's negative 2 sine of sum over 2 sine difference over 2. That is equals to 2 cosine 2x sine x over negative 2 sine 2x sine negative x. But sine negative x is negative sine x. The 2 cancel, the sine cancel, that's cotangent to x, which is our left-hand side. That's the end of the proof. Okay, that's for number 14. Oh, so I used number 14. I did number 14. Now let's apply that here. Yeah, use sum to product formula. Cosine plus cosine is equal to 2 cosine of sum over 2 cosine of difference over 2. That's something you will see the formula tomorrow. Or you can just look at the formula we have earlier there. So this is 2 cosine 3x cosine x equals to cosine x. Okay, now never divide by an expression that is possibly 0. Okay, so in this case, you will move the cosine x to the left-hand side and factor it. Okay, so we have 2, cosine x factor out times 2 cosine 3x minus 1 equals to 0. Okay, so cosine x equals to 0 or cosine 3x equals to 1/2. We need all the solutions in degree. So x equals to 90 degrees plus 180 degrees k. Yeah, cosine x is 0 at this position and this position. Okay, now cosine 3x equals to 1/2. There are two branches. Let me just do it this way. So 3x equals to pi over 6 plus, oh, I'm sorry, it's in degrees, 30 degrees. So that's 30 degrees, 60 degrees, not 30, 60 degrees plus 360 degrees K. Or in quadrant 4, that's 300 degrees plus 360 degrees K. Now then divide by 3. So x equals to 20 degrees plus 120 degrees K. X equals to 100 degrees plus 120 degrees K. So these are the solutions together with this. Okay. So I think I have done whatever I can here. Now let me go back to this. How can I check this without using calculator? How do I check this without using calculator? Now, I promise you, I will not give you this kind of question in your test 4. You know, this is way too much. It takes too much time. It takes too much time. Okay, it takes too much time. Now, but I'm trying to show you what if I try to check this. Okay, what if we try to check this? Let's try to check theta over 2. That's for number what? So you see a typo give me a lot of issue, right? Yeah, what end up happening is I add 5 points to everybody. Oh, just like your last test, I give a wrong direction. I have a typo in your very last question. The definition of attitude, I type it incorrectly. It's supposed to be CD. I typed AD, so I have to give 3 points to everybody because of the typo. So number 4, check. How do we check if the theta 2 is pi minus cosine inverse of 5 minus radical 17 over 4? Now, I don't guarantee you will understand what I'm doing here, but let's take a look. Okay, let's take a look. So theta over 2 will be theta over 2, pi over 2 minus 1/2 cosine inverse of 5 minus radical 17 over 4. Okay, now then let's take a look on what's the equation again? That's sine pi over 2 minus cosine theta. So sine theta over 2 minus cosine theta 2 equals to 1. Is it true? So this is actually sine pi over 2 minus 1/2 cosine inverse of 5 minus radical 17 over 4 minus cosine pi minus cosine inverse of 5 minus radical 17 over 4, is it equals to 1? Okay, now if this were our angle, call that angle alpha. Okay, so this is angle alpha here. This is angle alpha. Cosine inverse gives us angle, right? Now this is the same to say sine of pi over 2 minus alpha over 2, is it right? Minus cosine pi minus alpha, is it equals to 1? But this is actually sine pi over 2 minus blah is cosine alpha over 2. Okay, and then cosine for pi minus quadrant 1, that will be quadrant 2. Quadrant 2 is negative, so this becomes plus cosine alpha equals to 1. Is it equals to 1? Now, the thing is, if you look back, this alpha is cosine inverse something. So what happened here is this is cosine of cosine inverse of that ugly number, right? The cosine will cancel. So we will end up with 5 minus radical 17 over 4 for this branch here, for this part here. Okay, now while for this part, alpha over 2, that's alpha is in quadrant 1, right? It's in quadrant 1. So if you divide by 2, that's still quadrant 1. That's square root of 1 plus cosine alpha over 2. But that is the square root of 1 plus 5 minus square root of 17 over 4, big over 2, like that. Then you do some algebra here and there, see if that will give us 1. Okay, but it's actually something doable, but the level is a high level of precalculus. It is still your level though. I cannot really do too much because you have not learned that inverse trick, which we learn tomorrow. Okay, but even for that one is this is the heavy part. Okay, yeah, this is the heavy part. I think I will just stop here. Don't worry about this question number 4. Let me erase that here from here. Instead of saying that I do number 4, I did number 7 and number 14. Okay, and let me put a note here. This number 4 is too hard to do due to typo. So I cancel that question. Now the one you need to be prepared is you try this. The one you try cosine theta over 2 minus cosine theta equals to 1 instead. You try that one. Okay, let's see if that's doable. I believe that should be doable for cosine and cosine, right? That should be doable. Try that instead. Okay, now what I will do on Wednesday, then on Wednesday, I will continue doing the spring 20 and fall 20 with the questions that we will, with the topics that we will go over tomorrow in class. So tomorrow we'll go over 6.5, 6.6. Okay, and then on Wednesday, we will do question number 2 from here. Not that one yet. Not this one yet. Not this one yet. Okay, this one. So on spring 20, we will be able to do. Oh, not yet. Yeah, number 6 here. Okay, we'll be able. So it's just a little thing we can do on Wednesday, huh? And this one, number 2. So I plan that on Wednesday, take a look on spring 19. Take a look on spring 19. Give me a second. Fall 19, not spring 19. If you take a look on the discussion board today, yeah, fall 19. Look at the one from fall 19. Do as much as you can from there, such that on Wednesday, while waiting for material that we have not done, which we will go over on Monday next week, we also have another type of problems, another sets of problems that we already go over. Okay, see you then on Wednesday.